Thank you for joining me today, Stewart.
You're welcome.
So you've been the CTO of AWhere now for about 15 years, and you're also the co-founder.
Correct, yes.
And you've been working on developing data solutions to address global agriculture problems. So set the stage for me. What's the situation now, and where are we headed?
Yeah, so the situation today is the globe is really facing an enormous challenge. We're looking at increasing global population, and the challenge there is how we're going to feed that population. And then the second part of it is, the second challenge is weather variability, and they're the two things that we focus on. So by 2050, we're looking at a population of additional 2.4 billion people, and part of the challenge there is how we're going to feed those people. Most of the projections have those population growths happening in the developing world. And then where we look at the farmer populations that are going to be feeding those people, they also mostly are on smallholder holdings, smallholder farmers, so they're 1 to 2 acres. The challenge is how do we increase their productivity enough to be able to feed that growing population. And then in the face of weather variability, so climate change and increasing temperatures mean effectively, and we see this on the ground with our data, is more weather variability. And so farmers no longer know when it's going to rain. Historically, they knew when to plant. That's changing. And so this is a huge challenge with those two enormous problems. And add to that by 2050, with an increase of 2.4 billion people, there's only 34 growing seasons between now and then. And so this is a problem we need to solve now. Wow.
And so if we do nothing, what happens?
If we do nothing, I mean, people obviously adapt and resolve problems like this in various ways. But I think we'll be looking at some real crises that, part of the initiative of getting into global development in the US and European countries funding global development is to avoid these sorts of famine, disasters and events like that are just devastating to economies and to people. So I think that's the choice, is can we start to do something now to solve some of those problems to avoid some real crises later on.
Right, and one of the solutions you've developed is a platform called Weather Terrain. Talk to me a little bit about what that does and how it works.
Yeah, so Weather Terrain is a weather database. It's a global database. We cover all of the agricultural growing areas around the world. We have up to 20 years of daily weather history for any location on the planet in those agricultural areas. And we can build models on that data. We can look at risk, so we can go backwards through history and look at the risk of certain events. We can run forecasts and run pest and disease model forecasts on that data. That, in combination with other data sets that we pull, really give us a global view of the agricultural problem. And that's what Weather Terrain can really do. What we do is we run a model that gives us regularly spaced points every few kilometers, so it's high resolution. But we can also go down to the field to hyperlocal level, so model data, weather data to your exact field. And this is critical for agriculture because of the fine thresholds we're dealing with that affect plant growth and plant physiology.
And you talked a little bit about this, but what specific kinds of data are you gathering, and what methods are you using to gather and analyze it?
Yeah, so we pull data from many sources. On the weather side, it's a lot of satellite information, satellite radar, passive radar from NOAA, NASA programs. And then we combine that with ground observations. So there's global networks of weather stations that we pull in every day. So we're pulling this data in daily, processing it and pushing it through our system to our customers. And then you have what I call commodity station networks. So these are smaller, cheaper weather stations. A few $1,000s, you can get a weather station and put it in your backyard. So pulling in that type of data to fill in gaps that we have. And then we're looking at ground radar is another source. So in developed countries like the US and Australia and Europe, there's ground radar systems, those big circular bubbles you see that are detecting rainfall. And then we'll pull in data data from other sources like World Bank and FAO, World Food Program, to start to give us comparisons of other agricultural statistics and start to assess risk and target perhaps investments.
And so your main focus at AWhere is in working in developing nations. Why is that?
Well, we actually do work in both developing and developed countries. Some of our customers are some of the largest agribusinesses in the world. But we do have roots in Africa. That's where John Corbett, our CEO, and myself started working together. We worked at the Consultative Group for International Agricultural Research. This really came out of the Green Revolution, a collection of research groups around the world focusing on different crops. So we work together on connecting crop simulation models to weather data, and really that's sort of been our focus because we've always felt like that was, again, back to my earlier points on developing nations being critical to solve some of these problems, and so that's why that's been our focus. Where we are a for-profit company, but we work in the global development space. We work with Gates Foundation and USAID and groups like that. So we do look for revenue, but we also look for the number of farmers we can impact. That's one of the metrics we like to track. And it's why we're a B Corporation. We were just certified as a B Corporation last year.
And can you share a success story, an example from one of these local developing areas that you've been working in?
Yeah, actually, I was just on our call yesterday with a group in Ghana that we work with. They push information out to farmers via text messages, and they're looking for, it varies the sorts of information farmers are looking for, but one piece of information they were looking for was wind speed. And so we weren't providing that, and we added that to the user interface so that they could start to look at problems like threshing and control burning because they haven't got into the growing season yet. There'll be other problems we can solve with other forecast data, but that's the type of very practical information that we can provide to farmers through very simple delivery mechanisms.
And what kinds of logistical challenges do you face in working with developing nations?
Yeah, so there's definitely issues. I mean, connectivity is one. When John and I started working in Africa, this is 15, 20 years ago, we were producing software on CDs, giving it out to national ag researchers and NGOs working in the area because there really was no internet. Other people were all about developing web applications at the time. We focused on desktop for that reason. That's improved dramatically, of course. We've run our applications now in very remote locations, but it's still a consideration that getting to maybe a national ag research center is okay now, but getting to that farmer is a real challenge. They typically might have a feature phone. They're not going to have a smartphone, so you need to adapt your delivery of information to that format. And then there's challenges for financing for them around how can we make sure that they've got enough credit on their phones to receive text messages and maybe voicemails, which are more effective. You've got language issues, you've got literacy issues, and then rolling up to other problems around just policy and challenges around how do you operate in countries like that, and how do you work with local governments. There's a lot of interesting challenges for us in that space. But what we mostly do is work with partners. We find either private organizations working in the region, or we work with some of the international development agencies.
And you've opened your API to developers. What sorts of interesting things are you seeing being built?
Yeah, I mean, it's so fascinating because it's, weather is so fundamental to agriculture, and there's so many different ways you can leverage that. And so we see applications, for example, in the United States, you might have scouts in the field with iPad applications, and they're using high-resolution imagery so they send students out into the field to accurately identify pests and diseases, and so then they can scale their operations, and so they can use our weather data and our pest and disease forecast to help them know what to look for and narrow down what they should be looking for for and to mitigate misidentification of issues. Another example is some of our partners are building applications for drones and UAVs. So they can calibrate those drones to look for specific issues, pests and diseases again, and be able to, if they know what to look for and where to look for it, they can gain some efficiencies there. And then back to my earlier example in Africa, working with a group in Ghana, one of the applications there was sort of interesting because, like I said, they're delivering information to feature phones, and that's a challenge, and some of the farmers are not literate. And so you can use voicemail, but that's expensive. Text messages are cheaper. And so what we did was we collapsed our forecast down to a aggregate, so a smaller number of periods per day, and then we collapsed the forecast, like partly sunny, partly cloudy, windy, that sort of thing, down to a smaller bunch of categories. So they could convert that to ASCII character images on the feature phone. That gave the farmer something that was interpretable enough to take an action. So some pretty interesting applications that people are building on our platform.
And so the Internet of Things is playing quite a big role in your work. How do you see that developing and expanding in the future?
Yeah, it's pretty interesting, especially here in the US, where we've got lots of more affordable sensors coming out, soil moisture sensors, as I said earlier, smaller weather stations. How do you incorporate all of that data together? That's one of the things that we've really focused on, is building a platform that is flexible enough to be able to take in multiple data sources from multiple systems and integrate that together. The way we do that is we focus on location and time. So as long as you have a location and time, we can bring that into our platform. Doesn't matter what scale it's at. If you've got an aggregate level, maybe a forecast is a big block of space versus an individual sensor in the ground. The interesting thing is, how do we make those affordable enough for farmers both here in the US and then especially in Africa too? And then really what's the balance there between cost? We had precision farming for a long time, but it was really adopted by larger corporate organizations and large farms, not really affordable for smaller farmers. So how do we leverage that cheaper and cheaper sensors, get that information integrated in a way that makes sense and can provide value, and really decision support systems.
All right, yeah, that sounds like it's going to be really important for those local farmers down the road once that cost level comes down.
Right.
So to close our conversation today, I'm interested in a little broader of a picture of what people and projects are you following right now? What kinds of things are you finding interesting?
Yeah, I mean, I guess I'm a little boring in that I focus sort of on my work. It's I love what I do. So, things I'm really interested in, as you said, Internet of Things. I mean, I'm really curious about how small and cheap can we get some of these sensors. I mean, you can imagine temperature sensors don't have to be particularly elaborate. And that's really fascinating to me, is how can we improve monitoring our environment that allows us, gives us the information to provide really powerful tools for decision making. And then when we look at some of the drones, UAVs, and the sensors that they're putting on those, in combination with what they call microsatellites or nanosatellites, far cheaper satellites than we previously worked with. You've got groups like Digital Globe and NASA and NOAA putting up enormous satellites, and part of the challenge there is the cost. It's incredibly expensive to really be able to scale that and apply it to smallholder farmers. But there's groups working on nano satellites, very small satellites, breadbox-sized satellites, putting those up and being able to deliver that in an efficient, affordable way. And then I guess generally for big data, we look at spatial technologies and data types. That's very important to us. Just agriculture being such a spatial activity, we need to know where things are happening, why they're happening. And so spatial data types are particularly of interest to us in the big data space. And then finally, connectivity. We talked about that being a challenge in Africa, and some of the things that Facebook are looking to support, trying to increase connectivity in Africa, I think could create a huge groundswell in innovation happening in those geographies. So they're the main things that I'm sort of interested in and focus on.
Interesting. Thank you very much for talking with me today.
Thank you very much.